No, no, you can go right ahead.
Alright, so the pull request we were working on last time got a review from Carol, and I asked M.A. Lemberg, Mark Andre, sorry the name slipped. I asked Mark Andre if he wants to take a look, but I guess he's busy. So I'm giving it a final read through, and what I wanted to focus on is whether I use name everywhere rather than identifier. I want the more generic or more general name used everywhere here, and I think I'm almost done. I'll just merge it.
Okay.
Right, got a review. Probably want to put something like this in the commit message. And we are using Excite start and Excite continue. I don't think this is the case anymore. Is it? And we need to use Excite start, Excite continue. And I think I should include Mark Andre in this. Because he is the author of... No, this is the author, okay. Maybe should I include Martin as author since I borrowed some of the wording from this PEP? So Martin had his last commit 10 years ago. Probably not. Yeah, let's just keep the people on the stream there.
10 years is a long time.
Well, people come and go. Right, we do have an outstanding pull request here for rewording the F string and T string section. And here I'll just say I plan to merge this next week. I should really save this as like a saved reply, shouldn't I? So GitHub has this saved reply. And I need to add this there somehow. I don't remember how, so I'll
Save reply. Oh, that's cool.
yeah, it is. You want to look at what I have there? Might be interesting. Oh, pinging experts from the experts list on the dev guide. With a gentle nudge for people to remove them if they don't want to be pinged. Unsupported architecture reply. We don't get too many of those anymore. Please don't force push, that's a good one. Generic unsupported OS. And I'm reverting your pull request because it broke BuildBots. And a check one. Yeah. I need to go through that list more often because I forget what's on it and write it again. Anyway. So let's go on to the fun stuff, hopefully. This one is merged. There was this pull request on optional modules, which is now merged documentation-wise. There's a non-docs PR I need to get back to, but that kind of slipped off the priority list. Right. So let's go back to the subscription section. Remember that?
Oh, of course.
So that thing currently looks where do we have this? Subscriptions like this. And apparently we were last working on this 1,000 commits ago. So I'll merge in the main branch. And yes, we do have some conflicts. We have a merge conflict in parser.c. Wow, we were changing the parser. I don't remember that. Interesting. Anyway, the way to regenerate it is make regen all. But that will try to build Python, which you can't build because there's a conflict marker in the parser. So I need to use Python. Python for regen is my main Python. And that will regenerate the file. And let me commit the merge. And now that I have merged in the main branch, I can do a git diff or main and see what's changed. Maybe get the list of files first. So we have functions RST, data model RST, expressions RST, but the parser wasn't changed. maybe that include something that's already merged in main. So, oh, this was the big rewording of the subscription, right? And this one kind of has overflown into the data model, and I think one more place in the documentation.
Yeah.
Right. So let's see what's at data model RST in this line. Yeah, this is apparently a new list, and it's not a proper restructured text list because it doesn't have a blank line before it. So is this better? Yes.
Let's see. Yeah, nice.
Alright. So what are subscriptions like now? We have subscriptions and slicing. And I guess I need to follow out the links to see where they lead. So subscription syntax, selecting an item from a container to get a value from a dict. Dict is of course linked to dict. Object being subscripted, a primary, which is linked to 6.3, that's fine, is followed by a subscript in square brackets. In the simplest case, the subscript is a single expression. Depending on the object, the subscript is called a key, index, or type argument for generic types. Syntactic call. Oh, there's a typo. Syntactically, these are all equivalent. So subscripting a list using the index, parameterizing list using the type argument. Maybe we should say parameterizing the list type. That makes the line too long.
Oh, can we add like a non-breaking space or?
Oh, we should skip the markdown line syntax and code comments.
Okay.
At runtime, the interpreter will evaluate the primary and the subscript and call the primary's get item or class get item. Subscript other arguments for more details on which of these methods is called. See that thing. Alright, show how subscription works. We can define a custom object that implements get item and prints out the value of the subscript. Oh, this is nice. This is new. When you select things here, it doesn't select the prompt, so you can just paste it. That's nice. Now, see get item documentation for how built-in types handle subscription, including support for negative subscripts. So I just want to take a peek there. Yeah, that's this part that we will be touching. Right. And slicing, more advanced form is commonly used to extract a portion of a sequence. And this from the subscript is a slice. Blah, 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 and we have this slicing. Interpreter constructs a slice object with start stop step. Let's see the documentation for slice. Start and step default to none. Maybe we should improve the documentation here for slice, because I can see that these are documented as having empty bodies for these. So,
Yeah.
for example, if an automated tool wants to show you tooltips, it will show nothing. So
Okay.
let's go to functions RST and do this kind of drive-by commit. Yes. So the way to document all three at once is to skip this attribute dot dot, and then could probably use tab here, but it's 3 spaces and I'm used to my editor not set up for that. It is set up for that now. Anyways, let's see. So slice object have read-only data attributes, blah blah blah, which merely return the argument values. So pedantically, attributes don't return things. These read-only data attributes contain or are set to there. Slice objects are generated. Slice access use, for example, a start stop step or a start stop I. Huh. Right, this one's interesting. Why would you want to do that? See the tool slice for an alternate version that returns an iterator. That should probably be a separate paragraph. It's not really connected to when the slice object is being generated. And I guess let's move it up, this up here. That's a more substantial change than I had in mind, but I think it's looking better now. Right, let's go back. The slice object is passed to get item class, get item as above. So there we go. Tuple subscription. The subscript can be given as 2 or more comma separated expressions or slices. Commonly used for the numerical libraries. In this case, the interpreter constructs a tuple of the results and passes the tuple to That subscript may also be given as a single expression or a slice followed by a comma. Specify one element tuple. Start subscription. Subscript can also contain a star expression. In this case, the interpreter unpacks the result into a tuple and passes the tuple on. Star expressions may be combined with comma-separated expressions and slices. Right, formal grammar. I think this is fine. If subscript contains only one unstart slice without a trailing comma, it will validate the value of that slice. Otherwise, subscript will validate the tuple containing the items of subscript. Right, should we spend more words on the fact that these two alternatives are, well, the first one is technically redundant in the formal grammar, but the two things have different behavior.
Is it a semantic difference, maybe? I mean, I don't know. When would one slice? Maybe put in a note.
Oh, there's a note already, so maybe
There
I
is,
expand
yeah.
it somehow.
Yeah. I guess maybe not. I don't know.
Something like this. Is this too repetitive?
No, I think it's, well,
Maybe
what's it-
tuple
not a tuple.
slices.
Tuple slices, yeah. Yeah. There you go.
Right. Because when you go to college and learn about formal grammars, you learn that it's a tool for determining whether a piece of text matches the grammar, and they don't
Right.
spend that much time on, well, I guess the math doesn't spend that much time on getting parse trees or determining the meaning. So you
Yeah.
know, when I see formal grammar, I see this is redundant, right? Without
That's-
this,
yeah.
it will match exactly the same set of source code. So
Yep.
for people like me who remember this thing, we have this note now. Alright, and now we should go through all the other sections that are linked here. One here is emulating container types in the data model section. And did we actually change this? Yeah, we did change something in data model. Probably not in this section, which is good. I don't like what this section says.
Okay.
But on the other hand, I also don't want to rewrite this pull request because that would be another few meetings. Where do we link from? Oh, there's a container. Oh, and the reference name is sequence type too. Right, so where we did change something is this get item documentation, and this weird line here, those are git conflict markers. So let's see what we have there. Right, so I left these in last time we looked at this. So get item documentation, that's the thing we want to make better, and that is linked from here. Call the primary is get item. And there's also probably, oh, this is the main one. See get item documentation for how built-in types handle subscription, including support for negative subscripts. So this is what we want to see in that piece of docs, right? So get item is called to implement subscription, that is self-subscript. See subscriptions and slicing, that's the link right back for details on the syntax. There are two types of built-in objects that support subscription via get item. Sequences, where subscript also called index, should be an integer or a slice object. See sequence documentation for the expected behavior, including handling slice objects and negative indices. Right, so sequence documentation should then tell us about negative indices. I'm not sure about this note now, because this kind of makes you click here, and that makes you click again, so it's like a double link chasing.
I see.
And I wonder if we just want to remove that node. Just make it that.
Yeah, okay.
This will right. Okay. If subscript is of an inappropriate type, get item should raise type error. If subscript has an inappropriate value, get item should raise a lookup error, or one of its subclasses. Index error for sequences, key error for mappings. Ah, this looks good. Right.
Yeah.
And now we need this part. We need to make sure the documentation includes everything here. So let's see what this links to. So we have sequence documentation and mapping documentation. Sequences. Built-in function len returns the number of sequences. Index set contains the numbers. Item I of index. Oh, this is much too formal, I think, but let's not change it too much. We have negative subscripts. This should really say by counting from the end, not by adding the sequence length. Or maybe it should, you know, say counting from the end by adding the sequence length, or document this as the implementation of counting from the end.
Oh, cool. Yeah.
But I don't want to change this because that would be
Yeah.
a whole another rabbit hole.
Open up.
This does include interpreting negative subscripts and slicing. Right. So everything we promised is there. Good. Mapping documentation for mappings. So what's here? Finite sets of objects indexed by arbitrary index sets. Subscript notation selects the item indexed by K from the mapping A. This can be used in expressions and is the target of assignments of del statements. Ooh, del statements. Do we have del statements here? No. It's currently in a single intrinsic mapping. Oh, del statements. That's actually an interesting complication.
Oh, okay.
Because, right, we have slicing here, but we say nothing here about assigning to
That's true.
slices.
Yeah.
Right?
Uh-oh.
I wonder what happens if you, instead of this, do that. Type object does not support an item assignment. Good. Good. Okay. So, where is this covered? We have assignment expressions. Now this would be in simple statements. So where we have the assignment statement, which has a target list, which has a subscription. Aha. So yeah, assignment statements use the subscription grammar, but they don't really call get item and stuff. So let's see if this here, if the target is a subscription, the primary expression is the reference is evaluated. It should yield either a mutable yield. That's, you know, you can tell these docs were added before yield became a keyword, because now it's really confusing. It should evaluate either to a mutable sequence object or a mapping object. That's wrong. It can evaluate to anything that has a set item. User-defined objects, right? So we should give the same treatment to this, right? We should say the setItem method is called, and then the setItem method should give the semantics. But we'll go through this section later, so we're fine here. But it's correct as it is, and it's exactly as misleading as it was. So let's not do anything here. The del statement does not say what happens exactly, but it does mention subscriptions. But again, we'll go through this later. So this is questionable, but fine for now. Let's go back to here. I went through this. Right. And start deleting. So the formal syntax makes no special provision for negative slices. Here's a description of negative slices, which we have elsewhere. But I see this says x minus 1 selects the last item for x, which is much friendlier wording than the docs have here.
Yep.
So we do want to change this, and this is in the same file, so let me get a split and find where this happens. Oh, this has a minus 2 equals a n minus 2, the second to last item of sequence with the length n. Ah, this is almost the same thing as the last item, so I think we can remove this. We need this part. The resulting value must be a non-negative integer less than the number of items in the sequence. Otherwise, an index error is raised. This is nice. Since the support for negative indices and slicing occurs in the object's getItem method, subclasses overriding methods will need to explicitly add that support. Which I think is clear enough from the way we're now documenting get item. So we can remove this. And what's here now? A string is a special kind of sequence whose items are characters. A character is not a separate data type, but a string of exactly one character. Where does this come from? And we have sequences, immutable sequences, strings. String is a sequence of values that represent Unicode code points. All code points are in the range. This to that can be represented in a string. Python doesn't have a char type. Instead, every code point in the string is represented as a string object with length 1. Ah. Yes, this is true. And this is true, and it says the same thing as here. This is a bit friendlier. And it defines the term character. Let's see if we have an index in here. Character 1, 2. Oh, it's defined here. Which is interesting. So there's so if you're writing a book, here's something not to do. Make an index entry and don't refer to that index entry in the text.
Okay.
Let's see. There's a like the car. How do you pronounce this abbreviation? Should somehow tie character to Unicode code points.
Nice.
Now we repeat this, but I probably don't want to do like comma informally called characters.
Okay.
I know. A string is a sequence of values that represent characters.
Oh, there you go.
Formally,
Yeah. Right.
Unicode code points. And we can define this. now we say Python doesn't have dedicated character types. Yeah. Character type. Instead, every code point in the string is represented by a string object with length 1. The built-in function ord converts a code point from its string form to an integer in the range blah blah blah. This should have x because it's okay. So this is this is like the pedant in me screaming, right? So this is a hexadecimal literal, so it should start with OX, especially if we're putting it in these back quotes as a literal. And also this minus. I mean, if I see something as in like a code font, I would assume it's a Python expression. So this would be minus that, right? So I'd rather do it like this. And now this I can replace by 2.
Okay. Interesting.
Converts an integer in the range 0 to that, to the corresponding length 1 string object. Encode can be used to convert a string to bytes, and decodes can be used to achieve the opposite. Okay. Now, what is this stir encode here? What is this stir? Right. I should at least, say
ASCII?
it's a string.
Is this an old Python 2 thing left over?
Probably. Yeah. Before everything had a type, I guess.
Right.
Back when types and classes were 2 separate concepts. Should we give the same treatment to the others? No, we should just mark this up. Yeah, that should be enough. Okay, let's see how it looks rendered. Now this is, weird syntax. U plus 0, 0, 0, 0. U plus 10FFF. Why not use just this? People who know this Unicode style syntax will also know this one. And this one is probably more understandable. I think that's enough. Okay. Now this character index entry is alright being here, and we should put in string item. That's a character. Integer. Should there be an index entry for integer in the entry for strings? I don't think that's relevant anymore. Let me just remove that. Okay, now all the info in here is elsewhere, and we have a slicing selects a range of items in a sequence object. Slicings may be used as expressions or as targets in assignment or del statement. Huh. We need to put this somewhere. Here. Subscriptions may be used as expressions or may also be used as targets in assignment or del statement, and these should link to simple statements, assignment statement, assignment here. Or del statements. Let's see what that is. Del. I love these very simple targets. Do they have a better name? Deletion.
Yeah, deletion.
Instead of get item, we have set item. Need to put a verb somewhere here. There. Well, let's see how that looks. This is reasonably fine, but we want to follow this up with an example. Let's see. Need a better list for an example. What would be a good Monty Python list, for example? I know.
Okay.
Let's copy the list of the pythons from Wikipedia and just keep the first name so it's not too
First
obvious.
name. Okay, good. Yeah.
Oh, but we're about to delete one of them, which may be disrespectful.
Oh. How about if there's a duplicate? And delete one?
Duplicate.
In other words, do like Michael twice and then delete the second one? I don't know.
Well, there are 2 Terrys already.
Oh, that's right. There's 2 cherries. Okay.
Yeah, deleting one of these would be too disrespectful.
Yeah, I don't know.
Let's not do that. Let's
how
just
about
do
something with
colors,
next
I
one?
don't know. Red,
Sure.
blue, green.
How about red, blue, green, black, and then delete black? Or
Alright. So let's use 3 then. It's colors. This would be black. And you do we also need to set something, right? We can set it to white and then delete it. These colors, get the item number 3, set the item number 3, print out what colors are, delete, print out what the colors are, right. And now I want to use the same list in the earlier example. Number names isn't a very good example anyway. And let's we have the subscripting in the earlier example now. And I want to say that it'll call setItem or delItem respectively. Instead of getItem. And maybe note that all this thing.
Yep. Nice.
I have a type of it, don't I? Okay, good. Happy with it now. So, rewind. So we were here. Star assignment or del statements. Good. Now start. Oh, start slice object attribute. Stop slice object attribute. Steps slice object attribute. Let's look at the index. We should. That should be part of slice.
Okay.
Start slice attribute. Start slice object attribute. Okay, slice attribute is fine. Slice object attribute we can remove. We don't need that. We have the correct thing. Semantics for slicing as follows. The primer is indexed as normal description with a key that is constructed from the slices as follows, comma, conversion of a slice item, conversion of a proper slice. Yeah, we reworded all of that, but the information is present. We're good. Now, for loops, expect that an index error will be raised for illegal indexes to allow proper detection of the end of a sequence. When subscripting a class, the special class method class getItem may be called instead of getItem. See class item versus getItem for more details. Yep, sounds good. How do those notes look?
Nice.
shouldn't be a link, right? We're documenting get items, so these should all not be linked. But it should be marked as a method. So this is not just for loops. But also other kinds of stuff. What's the term for
the term for
language features?
perception?
Or maybe sequence iteration. Is this a good use of parentheses? I mean, I like putting parentheses everywhere I can, but it's not really good style.
Me too.
It's iteration protocol used, for example, in for loops expects that an indexer will be raised for illegal indexes to allow proper detection of the end of a sequence. When subscripting a class, the special class method class get item. Yeah, spot on. I think we're good here. Now, something linked to dict should be fine. Class get item versus get item. Okay, let's go. Actually, the subscription of an object using square brackets we'll call the get item instance method defined of the object's class. However, if the object being subscribed is itself a class, the class method class get item may be called instead. Class get item should return a generic alias object if it is properly defined. What if it's not?
Okay.
Type bool is not subscriptable. Okay. Sounds good. Okay. Presented with the expression object X, the Python interpreter follows something like the following process to decide whether getItem or class getItem should be called, right? Subscribe objects. Classes object is the type of object. If the classes object defines getItem, call class of getItem X. Okay, if the class has getItem, then return that. Else, if object is a class and defines class getItem, call object class getItem. So if is class, okay, and has either class getItem, then return class getItem. Okay. Else raise an exception. Right. I'm sure there's a very deep reason for this complexity. Oh, the reason is in Pep 560 if you want to read that. I don't think I want to read that right now. In Python, all classes are themselves instances of other classes. The class of a class is known as this class's metaclass, and most classes have the type class as their metaclass. Type does not define getItem, meaning that the expressions such as listInt, dict stir float, and tuple stir bytes all result in class getItem being called. Metaclass is a proper link, I guess. Oh, glossary, good. However, if the class has custom metaclass that defines getItem, subscribing the class might result in different behavior. An example of this can be found in the enum module. That's a good source of things that need weird quirks in the language. From enum import enum class menu.
Okay.
Right, so if you define a menu like this, then you can subscribe the class and get its items. So this would be the same as that, right? Enum meta defines getItem, so class getItem is not class, so you cannot use the generic stuff here like that. Alright, so good. So there's the reason for this complexity. And I quite like this. I mean, it's a weird feature, so it's kind of hidden in its own part of the docs. It starts with a nice summary, then gives all the gnarly details, and then goes on to give even more gnarly details. Yeah, I quite like this piece of the docs. So let's go on. getItem. We just spent some time here, and these are now things we already went through. What's this one? Oh, slice objects. This really needs deduplication. Why is slice.indices not documented along with the slice attributes? Okay, I don't want to touch this really, but that is sad. And we have slice defined here, del statement. It's fine, we'll look at that later. Right, so I think we're kind of done here.
I know.
Let's
Right.
make sure you're part of this. You're probably
Thank
created
you.
somewhere already. But alright, so what's left is to review the diff.
Okay.
So, in functions.rst, we changed something about slice objects. So let's what is, oh, library functions. Slice, right? And let's compare that with whatever we have on docspython.org. Slice. Alright, so what changed? This is the same thing. And then this says slice objects have read-only attributes, blah blah blah. Here we have proper markup for that. Slice objects are also generated when extending slicing syntax is used, where slicing syntax links to the proper section. See other tools iSlice, and these two things are moved to the top. These are kind of a detail, so I'll find, so I want them below the other docs. Right, this looks reasonable. Let's go on. The next change would be in reference data model. So instead of library functions, we put in reference data model. And the change is well, there's a link to sequences, but then there's stuff in the sequences. Alright, here. Why is this so small? Is it better in 315? Or is it my browser settings? Huh. Window size? Ah! Oh, no, okay. Good. So, we added here, the resulting value must be a non-negative integer less than the number of items in the sequence. If it is not, an index error is raised. We don't have that here, but it was somewhere where we took it out. This also supports slicing, and we, instead of I and J, we use start and stop. Comment above about negative subscripts, blah blah blah. that no errors is raised if a slice position is larger than the length of the sequence. There's a typo, so we're in data model. Start is missing or none. Slicing behaves as if start was 0. Stop is missing and behaves as if stuff was equal to the length of the sequence. That's important. Extended slicing with a third step parameter. Right, and then we go on. So this looks good. The next changed part would be in the strings. Let's see. There's this here. Oh, right after that. Right. The next changed things is linking the tuple and the byte, so that's probably good. Mappings gets a link, and then the get item is changed entirely. We recently went through that, so I want to mostly check that the missing, whatever's removed here is retained, like the information from here is retained. So it's called to implement the evaluation of self key, same thing here. For sequence types, blah 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 blah, negative indices, use type error, index error, we have that. For loops, subscriptions, I think we're good there. And now the main part, reference expressions. So subscriptions and slicings are combined. That's the main change here. So let's go to this page. Instead of reference data model, we have reference expressions. And we need to go to subscriptions and slicing, or subscriptions, right, subscriptions. And this is completely rewritten, so I don't want to compare it really, do I? So again, is everything removed still present somewhere?
Is everything removed?
Like whenever the pull request removes something, the information from that needs to be stay in the docs somewhere.
Oh, I see. I'm not really sure. I think so.
Primary must evaluate an object that supports subscription. Right. We don't have this as a condition. We say we call the get item, which is equivalent. I don't feel like defining an object that supports subscription. Oh, and what happens if it doesn't evaluate? So I think this is just better left out. Defining get item or class get item on the primary subscript, the evaluate this is so cumbersome. There's something about the comma. Start stuff cpip 646. Do we retain that? Yes. Retain that note until necessarily. Built-in objects, so we have that elsewhere. Negative indices, we have that elsewhere. Good, good, good. Right. Slicing. Right. Oh, there's a note. There is ambiguity in the formal syntax here. Anything that looks like an expression list also looks like a slice list. So any subscription can be interpreted as slicing. And we got rid of that very nicely because we have a peg grammar now which doesn't have ambiguities, so this is no longer true. And of course, subscriptions and slicing we now document as the same thing, so yes, one is a special case of the other. Rather than further complicating the syntax, this is disambiguate. Yeah, so much complexity we're getting rid of. Nice. Semantics of slicing. Yeah. Conversion of a slice. Oh, and that's it. Nice. All right. Okay, the grammar looks good. There's a lower bound, upper bound, and stride, which I think are actually present in the grammar. No. Oh, they're not. They were present in the previous grammar. Where's the previous grammar? Oh, yeah, lower bound, upper bound, and stride. So let me look at that again. Let's close this one. So the grammar says a slice is expression, colon, expression, colon, expression. And I like this aspect of the previous documentation where it calls the three expressions lower bound, upper bound, and stride. Because it makes the grammar... No, I lost it now, right? Because it makes the grammar more readable. Does that make sense?
Yeah. Yes. Yes.
I don't think it's. I don't think it's. Readable. I don't think this is important enough to. Whenever we get to generating this, to have some kind of special support for names, is it? Like if we go to the grammar, and instead of A, B, C, put like lower bound, and then here we put lower bound as well. This shouldn't really change anything. Now let's regenerate the parser. And what changed? The local variable names in the C code changed, right? So this has no effect on anything. And we probably want to do this later and somehow annotate that slice uses these names, right? Whenever we get to generating the grammar, which will take some time.
Okay.
Until then, we want to, get the grammar to a form we like. So this was nice about the old grammar, what I don't like what I don't like here is that these three numbers in slice objects are called start, stop, and step. And here we have lower bound, upper bound, and stride, which are.
Yeah.
I mean, stride is a nice term. I like it. Lower bound and upper bound are a bit questionable because you can have them other way around
Sure.
if the stride is negative.
Yeah.
So I would rather use start, stop, and step. And I don't know if these are now good rule names. Right? Now they feel much more like they should be expressed like something like this.
Hmm.
Like in the proper grammar, like this is
Right.
a name given to an expression.
Oh, that is nicer.
Well, we have a problem though.
Oh, okay.
We have a problem because we need to then define this in the meta grammar. Right?
Oh, I
When
see
we
what
go
you're saying.
to the introduction here, we need to say, you know, this we can name stuff. And that complexity makes it, I think, not worth it.
Okay, fair enough. Fair enough. Yeah.
Because there are very few places where we would need this. So I just go back to 3 expressions again. And given how much how much text we've spent on slicing here, and now we call this the formal grammar, I guess it's fine. Do you agree?
Yeah, I suppose so. No, I do.
Yeah. For formal grammar, I guess the other way we could do it with is some kind of comments. Then again, comments are probably better in the corresponding prose. Yeah, I'm convincing myself that, yeah. We just go with 3 expressions. And that's it. Is that really all? Wow.
Awesome.
So can we open open a pull request for this now. Is it time? So to open a pull request, we need to attach it to an issue, and we're no longer rewording the lexical analysis chapter of the docs.
Yay!
So this is continuing with that. So I guess we need to open a new issue. Yeah, let's do that. New issue. No. It's documentation. No, there's nothing. Continue with that. I'd like to reword and restructure the what's it? Expressions. And also this one. Okay. Anything else I need to do? Assign myself, I guess. Create. So we have an issue number now, and we put a link here. This let's list them all here. So we have expressions, simple statements, compound statements, and so on. Where was I? I lost it. So simple statements. Why does it put links in? Simple statements, compound statements. Don't want links. Top level components. Too many tabs open. And full grammar specification. Should I open a separate meta issue for all of these?
Maybe. I mean, they do have that whole sub-issue thing. I don't know if you can go the other way, though.
Well, this would be... I'd probably need to rename this one, but that shouldn't be a problem. This is about
Okay.
grammar snippets and a bunch of lexical analysis. Maybe later. So here's our issue number. Make a new pull request. Oh, no, this one. Oh dear. Okay, what do can I do something similar to what we did somewhere here, simplify docs. Yeah, this simplifies the subscription section. And slicings. Merges. Reorganize is fine. Sections in the language reference. Parser point of view, slicing is special case of subscription, and it makes sense. The PR also touches data model. Documentation, I've tried to move docs of the runtime behavior there. And to duplicate. My fingers are tired.
Yeah.
Class attribute docs. Uses the term subscript for the key index, whatever, in the subscript for the. Which reminds me, should we have a glossary entry for that?
Oh, yeah.
There's glossary. Subscript.
I thought we did.
Yeah, I probably
Yeah.
talked about adding it. Yeah, let's go at it. Glossary. DTU, so it should go here, right? The where is this? Expression in the square brackets of subscription. Expression usually used to select an element of a container. So called a key. Do we have an entry for key? No.
E? Oh. For value?
Do we have index? No. We need more glossary entries.
Okay.
Do we have
Should we make it
a
outright?
glossary entry for mapping? Yes. Do we have a glossary entry for sequence? Yes. Good. Okay, so now we need to add key. do how do you word this?
Let's see here. About also subscript. Oh, about it's not a value. Oh, the value of. A key is a token that points to an index.
Oh. Then we have to define what a token is, right?
Or a key is a symbol or a string.
A value that names.
Oh, okay. Wait, a value.
Names an entry in a mapping. Okay, this is too much and we're out of time. So, where am I creating the pull request? Comparing here. Would be a draft pull request then. Let's see what we also changed. Yeah, I think we're good. Alright. Yay. Let's see all the issues the link to finds, but we'll take a look next week. Thank you for enduring this with me.
Hey, no. Thank you.
And see you next week.